Hello, colleagues. Um, Hope we are all doing fine. Today, our subject is on combinations and permutations. Okay, so combinations and permutations are concepts that are usually very applicable in a lot of you know branches of mathematics, say statistics, probability, and a lot of them actually. You would actually notice that these concepts come from a branch of mathematics called combinatorics. Okay, that is just a vastness of, of combinations. So that's where it delves in. Okay, but what is the what are these things? What is combination? What is permutation? Okay, contrary to what we know in normal English vocabulary, combinations are ways in which we can select uh, a particular number of items from a group of items. Okay, so if we have a group of 10 people, how many ways can I select maybe 3 people from that number? Okay, so if I have say A, B, C, and D, so if I want to select 2 letters from this particular group, okay, how do I do it? So I know for sure that I have A, B there, so I can select these 2. I can also select B, C. I can also select C, D, okay. I can also select A, C, or B, D, and the like. So basically, these are different ways I can select 2 items or 2 letters from this particular group of items. Okay. Now, under combination, order doesn't matter. Okay. So if I select A, B, in the second round I select B, A. I don't care about the order. This is the same as this one. Okay. AB is the same as BA. They have the same letters. So if I get the word they, and I want to select 3 letters from this word they, even if I were to get T, E, H, this is the same as they. It is the same as T, H, E. So the order doesn't matter as long as the characters of the word or of the selection are the same. It means the same. Whilst when we are looking at permutations, it is the way, or it is the number of ways in which we can arrange items, specific number of items from a particular group of items. Okay, so if I have A, B, and C, and for permutation, I must say that the order is very important. So if I have a group of these letters, okay, A, B, and C, then I'm told to select, how many ways can I select 2 letters from this group? Okay, I know I can select A and B. I mean, I can arrange, sorry, I'm using the word arrange, under permutation, arrange. So this is one way I can arrange two letters from this particular group. And I can also arrange the letters that I decide to pick as BA. I can also decide to select BC and CB. I can also decide to select AC and CA. Okay, so these are the different ways I can arrange these particular letters. So if I'm to only pick 2, this is the way I can arrange them. Okay, these are the different ways I can arrange them. Okay, now if you look at the two concepts, what we are saying that under permutation, this particular set is different. AB is not the same as BA. If I have arranged AB in this way, if I decide to arrange BA, regardless of the characters being the same, but because the order in which they are arranged is different, they are not identical, they are different. So under permutation, these two stand out as distinct. Under combination, if I get AB and BA is going to be the same as AB because the characters in this particular combination are the same. Okay. Now, how do I identify that this question is requiring a combination set of or kind of a formula or a permutation kind of a formula? There are keywords. So if I am dealing with combination, the keyword under combination is select. Okay, I am selecting from. Okay, so if you see this word as a keyword, try to connect it with combination. But under permutation, you realize that the keyword there is arranging. Arrange. Okay, it has to do with the way I arrange. Okay, this is the keyword. Okay, you have a question and it is talking about arranging. You must be quick to connect it to permutation. If you have a question having a line of selecting, you must rush to combination. Okay, you could have maybe a few exceptions here and there, but the general rule is select is with combination and arrange is with permutation. Okay, having created this particular background, we have a question. A club has 20 members. They are to select 3. Again, you've seen the keyword there. Select. They are to select 3 official office holders. President, secretary, and treasurer. So those are the 3 positions. Now, they always select these offices or these office holders by drawing 3 names randomly from the names of all members. The first person selected becomes the president, the second is the secretary, and the third one takes over the treasurer. Thus, the order in which 3 names are selected from the 20 names is important. So basically here they are telling you that the order in which you actually select is very important. Okay. And what did we say about order? Whenever you have a concept of order, where the order is important, it is permutation. Okay. Find the total number of arrangements of 3 names from these 20. Again, you see here. Now, remember I had said the word select and arrange can sometimes, you might have a mix of them. But here, what is resounding here, you've been totally told that the order is important, and you have also seen the arrangement there. So meaning you are confident that what you're dealing with is permutation. Now, what is the formula for permutation? How do you calculate permutations? Okay, as the actual word permutation, you have P, you have N on top, and you have R there is equal to N factorial divided by open brackets N minus R open brackets or close brackets factorial. This is a formula for permutation. Okay, now where N is a total number from where you are selecting. Okay, so if we are talking about 20 club members here, 20 becomes your n, right? So total set of selections. Okay, then we have R there as our selected items. Okay, the ones we are picking becomes our R. So in our case, okay, we collect data. Okay, we collect data. We know that our n in this case is 20 because they are the 20. The club has 20 members. R, we need to select 3 from the 20, right? Based off this statement there. We need 3 names from the 20, meaning our R becomes 3. Okay. Now we get our formula and replace where n. So we know n there then is 20 divided by n 20 minus, and there's a factorial there, minus r, which is 3 factorial. Okay, so this then becomes 20 factorial divided by 20 minus 18. That gives us 17, right? 17 factorial. Okay. Now to expand this, I can basically 20 factorial means 20 times 19 times, like multiplying every lower number from the 20. So 20 multiplied by 19 multiplied by 18 multiplied by 17 up to 1. Okay. 17 factorial means multiplying 17 by all the other lower numbers. Okay. So if you notice, if I say 20 multiplied by 19 multiplied by 18 multiplied by 17 factorial. So meaning this one also, it goes on and on, and I can divide it by 17 factorial. If you notice that there is a 17 factorial and the 17 factorial here, this can cancel with that one. Okay, meaning I will remain with 20 multiplied by 19 multiplied by 18. Okay, and what does that give us? We have 20 multiplied by 19 multiplied by 18. We have 6,840 as our as the way in which we can combine or arrange these particular 3 members in which we select, and where the first one becomes the president, the second one the secretary, and the third as the treasurer. Basically, we can arrange these 3 names in 6,840. Okay, so the next lecture is going to deal with combination. Okay, we are going to deal with combination. So I hope it was clear. So under permutation, what the keyword is arrange. So when you see arrangement and order, okay, if you are looking at the ordering, mattering, or matters, that is your permutation. And the formula for permutation is n factorial divided by a open brackets, or in brackets n minus r factorial. Okay, and basically our n is the total number of items in a particular group from which we get to select. Our r is the number that is being selected from the group. Okay, and we eventually get to that particular point. So that is about permutations.